Hi, this is Ms. Delosier, and these are your notes on homology and evidence for evolution. So homology is when we're talking about organisms that have similar characteristics that are resulting from a common ancestry. So they have a shared ancestry between the organisms. So you have traits that demonstrate the organisms share a common ancestor. So there's all sorts of different traits that we can look at. The first one that I want to actually look at is the forearm. So we're going to look at the forearms of several different organisms. So that's the forearm of a whale, and this is the forearm of a horse, and this is the forearm of a human. You guys should be familiar with this one. Bones get a little small in this one. And the forearm of a bat, getting a little weirder looking. But what you can notice in all of those is that there's one large bone up at the top by their names. And that's in us, that's the humerus. And then there's two bones in most of these organisms. You can see in the horse it's kind of fused together, but there's two bones here, our radius and our ulna here. But there's two bones in all of those. And then you have the our phalanges, our fingers. There's five phalanges, and in the horse what's happening is if you actually if I was a better artist, or if we zoomed in more, you could see that you're getting a fusing of those bones together. But you basically can see through the forearm, the forelimb rather, the forelimb of these organisms, that they have similar bones. The second type of homology is molecular homology, and molecular homology is a little different. Oh, in the forelimb, the things that are similar is the number of the bones and the arrangement of the bones. We already talked about that. In the molecular homology, what you're seeing is that organisms are sharing genes. So if you actually go through and you sequence the DNA of these organisms, you'll see that there's a lot of genes that are basically the same genes. And so the more closely related the two species are, the more the DNA sequences are identical. So the closer the DNA sequences are to one another, the more molecular homology there are, and the closer related those organisms are. And the gene that we're going to use the most for this in class is going to be hemoglobin. So we'll look a lot at hemoglobin and what organisms have pretty much identical hemoglobin to humans, and then we can kind of look at how distantly related different species are based on how different their hemoglobin molecule is from ours. And the next thing I want to talk about with the homology is the concept of vestigial structures. So we've talked about this a little bit. A vestigial structure is a remnant structure. So it's a remnant of features that served a function in a common ancestor or in an organism's ancestor, but no longer serves a function. So let's look at the whale. The whale's a vertebrate, it's a mammal. And so let's draw its spine in. And then the whale, and you don't see this because it's actually inside the whale's body, but the whale, there's its vertebral column. The whale actually has a pelvic bone, and it actually has a femur. And there's no real point or purpose for that, right? Because whales aren't walking around, so they don't need a femur. For those of you that don't remember what a femur is, it's your thigh bone on you. So these whales have evidence of a pelvic bone and a femur, and what that's letting us know is that at some point they were terrestrial mammals. So these are vestigial structures, and that's evidence that the ancestor of whales was actually a terrestrial mammal. And there's all sorts of evidence of vestigial structures. The easiest one to identify in us is our tailbone. Our tailbone is evidence that at some point an ancestor to humans had a tail. And that's seen throughout mammals, that they have that tailbone. So I hope that helps you understand what homology is and what homologous structures are. Homologous structures are structures that might have a different function, but they share a common ancestry. And vestigial structures are structures that are remnants of an organism's ancestors. And one of the things that I want to mention is that the reason that this pelvis and this femur haven't completely gone away is because evolution isn't directed that way. It's not going to just, well, I'm not using the femur, so it's gone. What happens is as mutations accumulate in the organism's genome, mutations that affect the pelvis and the femur may or may not be selected for or against. So what happens is if that leg is sticking out and that's creating drag on the whale, and that makes the whale swim slower and makes it more susceptible to predators or less likely to go ahead and get its food, then you would have selection against that, that structure. But in the case of this pelvis and this femur that are inside the body, it's not actually doing anything to affect the whale's hydrodynamics, so you wouldn't actually expect to see those structures go away. What you would expect to see is that just more mutations would accumulate in the genes for those structures. But they're not actually really going anywhere. They're just vestigial structures. They're just remnants. So I hope that helps, and if you have any questions, please come on in and let's talk about it.